everyone. Thanks for having me. My name is Ksenija Blažević, accent is for the A. And today we're going to speak about features and products that can be built with generative AI. Before we start, a few words about me. I've been the head of machine learning and artificial intelligence at ex-LeroyMerlin for more than 5 years. I work in the field of applied machine learning for over 12 years. Yeah, I always forget this. And I've been working for major companies in banking, telecommunication, and retail sectors, mostly in Russian. But now my sphere of interest lies within neuroscience and philosophy of artificial intelligence. I'll be happy to chat with any of you on that topic. So if you feel like it, please feel free to contact me. You'll see my socials in the last slides. Okay, let's start. So why was this talk created in the first place? I'd say that the topic of generative artificial intelligence has been a bit overhyped recently. Please raise your hands if you support this idea. Yeah, good. Almost everyone supports. So yeah, many business leaders felt pressured to start implementing generative AI solutions, and my company was exactly like that. So I created a little course on generative AI solutions, mostly for product owners and business leaders, to help them implement more robust, more sensible, and more quality solutions with generative artificial intelligence. And this talk is a part of that course. So today I will walk you through 5 types of products and features with examples. And in the end, you will learn how to choose the right type of generative AI solutions for your product or your feature, and also understand how to assess resources, costs of development, expertise needed, data infrastructure, and also how to evaluate risks and security issues. And in the end, you will have a checklist of essential questions that you should consider before starting any deployment of generative AI solutions. Before we start, I would define some terms just to be aligned, just to stay on the same page. And as generative AI is a relatively fresh field, there are no common terms, so I just picked up some of them that are most commonly used. First of all, what is Gen AI? Gen AI, or generative artificial intelligence, usually refers to large generative neural networks and services based on them. Hard prompting. Who has used ChatGPT? Everyone. So you know what hard prompting is. It's manually designing prompts and sometimes using such techniques as few-shot prompts and chain of thoughts. Soft prompting. Soft prompting is a technique that allows you to tailor large neural network, mostly large language model, to your specific tasks without retraining the whole foundation model. Usually you just provide some specifically learned prompts and put them into the context of your initial request. Then fine-tuning. Fine-tuning is a process of adapting a pre-trained model for specific tasks using one of these techniques. Usually it involves retraining only a few layers of the large model underneath your system. Guardrails. Guardrails is a set of rules and protocols that are designed to govern behavior and output of your Gen AI system. They could be both made with heuristics or some machine learning or artificial intelligence. And then finally, RAGs, or retrieval augmented generation, is a technique that involves sending a set of facts and documents along with the query from some external sources. And that allows you to provide external up-to-date information to your model. So, what are those 5 types? And why did I decide to pick these exact types? As you will see, these 5 types are tailored to DIY sector, but could be applied, I'd say, to any retail sector, and then mostly to any company that works with customers. The 5 sectors, or the 5 types are the first one. And what I did, I reviewed the whole backlog of potential generative AI tasks that existed in our company, and then grouped them by the costs, by the time to develop, and also the potential profit that those initiatives could bring our business. So thus the 5 types. First one are out-of-the-box solutions, which are usually some functionalities or tools provided by some vendor. I think most of you know some of them, for example, Photoshop, Notion, Microsoft 365, and so on. The next type is Gen AI as a service, when we use some ready-made model by hard prompting mostly. The examples could be ChatGPT, Midjourney, etc. Also, I think most of you know what it is. Then the second type, like third type under number 2, is basically type 1, but enhanced with some additional components. And these components could be guardrails, rugs, agents, soft prompting, etc. Type number 3, my favorite one, are fine-tuned foundation models. When we pick up some mostly open source large model and then adapt it with our data. And fourth type is the proprietary large models that we build from scratch. So you can see from this slide that type 2 and type 3 are most appealing in terms of profit and in terms of number of cases. But type 0 and type 1 could be the low-hanging fruit of generative AI in your company. So let's dive into each type, and I will follow the same pattern for each of the types. So I'll give a brief overview of the type. Then we'll see when you should or shouldn't use this type. We'll dive into pros, cons, and challenges of each type, and then I'll provide some examples of solutions that we have implemented in my company. So, type 0, out-of-the-box solutions. As I've already said, those are tools or functionality provided as part of a vendor's packaged solution. Mostly, these are some solutions that have already existed in the market, but now are AI-powered. So, could you name any other? Okay. So, the example from the previous page was like Microsoft Office 365, Zoom, Notion. Yeah. There are only a few points I want to highlight about this type. So let's go. When should you use type 0? Mostly when you want to speed up tasks that were manual. Yeah, so those are some kind of co-pilots or assistants that will make manual tasks faster. And another use case is to automate very standardized workflows. Where you could use it, like in tasks for graphic design, for creating visuals, some basic communication, simple bots, training simulators, so on. And the main pro of this type is that implementing it is very straightforward. You basically don't need any expertise within your company. Also, all the support is provided by vendor, the costs are transparent, so on. The main disadvantages is that you hardly can develop any unique products or features with type 0 solutions. And my favorite tricky thing about type 0 is that market nowadays is flooded with solutions that pretend to be type 0, but are actually type 2 or type 3, and require you to retrain large models with your own data. But hopefully you have this guide and you won't be tricked. Type 1. Now the interesting part begins. Type 1, it's generative AI as a service when we use pre-trained models and provide them with some hard prompts. When should you use type 1? I'd say that when your output could be organized according to a certain pattern on template, it's the proper time to use type 1. And most of the use cases refer to classic natural language processing tasks, such as entity recognition, text classification, sentiment analysis, text generation, text summarization, and so on. Also, some tasks of image generation and painting could be solved with GenAI as a service. The main advantage is that it's quite simple, quite fast, and not that expensive. Also, if we use GenAI as a service, all the model support is on the service provider side. The disadvantages are usually that the use cases are still quite limited, and the main disadvantage is the quality control challenges, as most of these models tend to hallucinate. Who knows what hallucination is? Yeah, thanks. So yeah. And the challenge with type 1, yes, it looks quite simple, it looks quite cheap, quite straightforward, but never overlook the accompanying development and especially data integrations. Let's see some examples. When we talk about GenAI as a service, I think the first idea that comes to mind is the product description generation. And actually, this idea is not that original because Amazon has created it and now provides as a service for its merchants. We implemented it too. Well, having a nice human readable description description is very important because it is more attractive to our customers. So it raises the conversion rate from views to actual purchase. Also, it's well indexed by the search engines, and thus it attracts more traffic to our website. What you could see on this slide is to the left is the actual description that was AI generated for some foldable bucket, and to the right you can see the instructions that we used to do it. And as you can see, the instructions are quite complex. So before we implemented that solution, we had few contractors who did the description for the items. And the AI-generated descriptions not only complied with our KPIs on uniqueness, spam, and verbosity, they actually outperformed one of our contractors. And the tests have shown that add-to-cart rates and traffic were comparable to human-constructed descriptions and performed really well compared to the items that had no description at all. And thus, with the implementation of this solution, we got each description to be 98% cheaper, and time to market of each description dropped from 14 days to 1 day, so made it 14 times faster. Another solution of this type is extracting attributes from unstructured descriptions that we get from our suppliers. And this helped us enhance the parsing quality by 10% compared to the heuristic solution that we had previously. And the attribute completeness that we now have on our product cards on our website raised by 5%. Regarding the creating images, like we have two solutions. One of them is generating product images in interior settings when we have a photo provided by a supplier and we need to paint this photo into some surrounding, into the interior. And another one is transforming photos according to company guidelines. And this, like total savings, were 30 times for stock photos and 200 times for saving on photo shoots. For the tasks of painting images in interior settings. Now, type 2, GenAI as a service, enhanced with some additional components. So as you can see from this image, the system could become very complex, like a sandwich, when you stack those components on it. And first component that we will discuss is guardrails. When should you consider using guardrails? Usually, it's when you want to enhance the performance of generative AI as a service, adding some additional business logic, adding some heuristics, or if you wanted to adhere to scripts and workflows. Another main case is when you want your solution to adhere to some policies. This could be ethics, security policies, or any other form of compliance policies. And then I'd say that you should always consider using guardrails when you don't have any manual validation in the loop of your system. The main advantages of guardrails is that most expertise usually is on the business side, so you don't need some very expensive competence in data science and machine learning. And also that it usually allows you to eliminate the manual validation step, which could be quite costly. And the main disadvantage is that some guardrails can be very challenging to implement. For example, if they require machine learning, sometimes you get a cascade of machine learning models to assess a simple output. So it could be quite costly and not so easy to maintain and support. Then another component that could be used in type 2 is retrieval augmented generation. You should consider using retrieval augmented generation when you need access to external data and when your domain data changes over time. The main use cases are usually also all the NLP tasks, and when you could imagine something like a search system, this is it. So this could be search and responses based on some documentation. That could be some automated hints for support staff, and also creation of simple auto responses or something like that. And the main feature of retrieval augmented generation is that usually you're able to analyze sources and provide the reference for exact part of documentation on which your answer is based. The advantages is that it's relatively simple way to integrate some external data. And main disadvantages is that it usually requires a solid knowledge base, which isn't always present. And the search quality is quite essential. And achieving nice search quality is a very challenging task on its own. Third component is soft prompts as a service. And you should consider thinking about using soft prompts when you have natural language understanding tasks where the base model performs insufficiently. And main advantages is that if you're tuning the provider's side, tuning it on the provider side, then you only need to prepare a small data set. And you don't need to organize the whole tuning process. You don't need to think about large language model operations and stuff. And the disadvantages is that it's usually more costly than just using type 1 solutions. And you still need some quality training examples that sometimes are quite hard to obtain. Now about challenges. I'd say that this is my favorite group of challenges because there is some seeming simplicity in implementing type 2. There are many tutorials that say how it's nice and easy to make a rug out of ready-made components. Also, when you think about guardrails, you usually imagine just a simple web service with some heuristics in it, and so on. So just take ready-made components and create something nice and big around Gen AI as a service. But the reality is that when you take those components, they are never tailored to function properly with each other. And what you get in the end, you just sew it in some kind of Frankenstein with multiple points of failure. And usually they start to fail quite quickly, like maybe after a few weeks of your service being in production. Another challenge is security issues, particularly those related to prompt injection if we're talking of systems based on RAGs. If we talk about examples, they are quite simple, I'd say, the ones that we have in my company. First one is the classification of requests that come to support team, and then automatic response based on documentations for those issues that could be answered automatically. And another one is a system that allows handling of very complex legal documents, like search and tagging and scanning of documents related to product characteristics, documents for transactions, transportation, incorporation documents, etc. Then type 3, my favorite one, fine-tuned foundation models, when we take open source models and then tune them with our business data. When should we consider using type 3 and tuning some large models ourselves? First of all is when you need you have your own domain data and it contains very specific knowledge and terms and concept, and your system has to handle it. And another point that this concept do not change over time quite rapidly, because otherwise you would try to use a RAG. The prerequisites are that you should have a large data set available for model tuning, and you don't want to analyze the responses or provide links to sources. You'll find that your model has this specific knowledge and just gives answers like based on its own expertise. The use cases, I'd say natural language understanding from a very narrow domain area. So it could be any kinds of chatbots. So I'd say if you imagine a chatbot or some expert level knowledge system, then you should go for type 3. Advantages is high performance after training, if you don't fail while you train it, and knowledge of specific domain. The disadvantages is that it's quite complex and time consuming. You require quite a lot of quite specific and expensive expertise and competencies. And in the end, you will get a service that is also prone to hallucinations as any other. And to reduce them, you'll need to build like a huge amount of guardrails. Another disadvantage, I think it may be quite important if you're watching this, is that there are very few quality foundation models for languages other than English. And the less the language is spoken, the fewer are the options. And now the main challenge that is always overseen when people try to fine-tune or retrain large models is large language model operations. It's very tedious, it's very expensive, it requires a lot of time and expertise. So please keep in mind that you need it. Now the examples. One of my favorite examples that we have already built and now are testing is a new generation of search engine for our website. Previously, if we typed something like this, like I want to drill a concrete wall, I wouldn't get any results at all. While what I really want to get are some hammer drills. So now we have search engine, which is based on jobs to be done and customer intentions, which is really cool. And another thing that we are currently working on is the next generation of complementary goods, when we use classic machine learning approach and some automated expertise. So we have already had complementary goods based on machine learning, based on the purchase statistics and history, but we wanted to incorporate some specific expertise that our employees had, and that is not visible in large amounts of data. So now we are working on something like that, and we want now to get complementary goods like chisel and extension cords and the thing in the middle. I don't know what the name is. Does anyone know the name in English for this? I guess no one. Okay. And finally, type 4, proprietary large models that you train from scratch. And I'd say it's every CEO's dream. But my advice is just don't. If you have listened until this point and you're still entertained by this presentation, then probably type 4 isn't for you. For reference, I'd say that training a large neural network, which is comparable to GPT 3.5, is quite expensive. It's around $500,000. But if you have that money and still are willing to train a large language model, you could always call me. The context will be on the last slide. But if you have competencies and an understanding that training a compact generative neural network can solve your problem, it is worth to try it. For example, we have trained a transformer model for processing abbreviations in product descriptions. Sadly, the screenshot is in Russian and also quite small. I can read the thing, but you can see that we are processing abbreviations quite nicely and getting the full description and full naming for each of the products. And this large model is relatively small. It only has 60 millions of parameters, and it costs us around $30,000 to train this model. So these were the 4 types, like 5 types, I'm sorry. And this is a summary table. You can always refer to it and see all the comparison between the table, how they how resilient they are to malicious behavior, to compliance things, to hallucinations, and so on. So just know that this slide is present, and that's it. And now let's finally deep dive into the resources assessment. I don't want to pay attention to type 0 because usually the costs vary greatly and also are very explicitly stated by the vendors. So we'll go through type 1 to type 4, from type 1 to type 4. And also I'll focus on data, the cost of retraining an infrastructure, and the cost of inference, because I find it's the most challenging part. Regarding data examples that you need, you can see that for type 1, you only need from 5 to 10 examples, which is quite a few, while for type 4, is training your own large model, it could be an infinite number of examples. When we talk about the cost of training or retraining, these estimates are quite conservative, and you must keep in mind that these prices change quite rapidly as new vendors enter the market, and some of them provide quite affordable prices. So I'd say these were the prices for the end of summer 2024. I guess that by mid-2025, they will drop in half. It's my estimate. I don't know if that will be right or wrong. Then the most tricky part was estimating the cost of inference. It's actually, I think, the most important parameter for each of these types. And to do so, I collected whole tasks from our backlog that were connected to generative AI. Then I very roughly estimated the number of input and output tokens for each of the tasks, and also estimated the number of requests per day which each of these systems required. Then I averaged it all. Then for types 1 and types 2 that require some Gen AI as a service, I looked both for the cheapest options on the market and the high-end options in the market. And for types 3 and types 4, I estimated the rental cost for infrastructure that could host a mediocre model for a day, the rental cost for a day for a mediocre model, and then just divided it by the average number of requests. And the interesting fact here is that owning and serving your own large model becomes more cost efficient once you get over 1,200 requests per day. So in terms of time of development, you could see it's from 1 to 3 months to GenAI as a service, our type 1, to over 6 months. And I would say that you're lucky if you finish it in 6 months when we talk about type 4. So I'd say that mostly your own large models will take around 1 year and more to train and to acquire some tolerable quality of output. Now, the checklist of questions that you should consider before starting any GenAI development. I'll just go very briefly over them, and you could always refer to them later if you want to. This is the block of questions which is the most important. And the most important question in this block of questions is how to evaluate the quality of the output. If you do not know the answer for this, you should just stop any development and think again. Other sets of questions is how sensitive is the solution to errors and poor output? And it also brings you back to validation. Then can validation be integrated into the business process? Because if not, you should stop any development and also think again. And final question is that can business logic be used to guarantee a quality result? Because if not, you'll have to implement something like human in the loop or other manual types of validation. Then a few questions regarding data. Whether you have some digitized expertise available in your relevant domain area. Do you have any training data examples available already, or you have to collect it? And of which quality those examples are? And then some basic technical data requirements like frequency of data updates, access to external sources, etc. That would all add up to the final cost of your solution. Security issues. You should always consider security issues if you're working with some sensitive data. It could be the personal data of your users or some sensitive data corporate secrets of your company. So you should always think if you face some ethic risks, data exposure, prompt injections, etc. And if you are using types 1 or types 2 solutions, the GenAI as a service enhanced with something, there are some issues that should be addressed to the provider of such service. Like, does this provider have any certifications to work with sensitive data? Who is in charge of the environment the model is deployed in? What is legal responsibility of the provider if you violate some compliance or ethic risks or something? Who has the ownership right on the model or the system? Because all of this can bring you to major risks in the future. And finally, my favorite block of questions is the large language model operations. Those are mostly technical questions, but each of these blocks adds up to the overall price of your solution. So basically that's it. It's just some advice that you haven't asked for, but I will give you anyway. These pieces of advice help my company a lot, and I hope that they might be useful for you too. First, and I think one of the most important, is that try to enhance understanding of what generative AI solutions are and what are their limitations, because it will drastically reduce of some stupid initiatives. It helped a lot. Like I'd say that maybe 80% of the ideas were cut off after that course that I led in my company. Then always try to find a budget-friendly way to test your Gen AI hypothesis and before you start to conduct some research. For example, you can start testing with prompt engineering and always try to select the minimally suitable type of solution. Even if your gut feeling tells you that you should train your own large proprietary model, please try with ChatGPT. Probably it will do. Then there is another trick which is quite handy. You can always use a more expensive model. Usually those are models provided as a service to create the training data set for training your own less expensive model. That helps a lot. And finally, I'd say this is the highlight of this talk. Please remember, the closer the generative AI solution is to the external user, the higher are the risks. So please remember about validation that you saw on a few slides before. That's it.